What inspires you most at Sega?
What inspires me most at Sega is knowing that everybody at least interacted with Sega technology once today without even noticing.
We are the embedded experts because we have a solution for every embedded problem.
You can see us as a tool provider for other people that also make products. So if you build a house, you need a hammer, you need a drill. We are that kind of company, but for software engineers.
Debug and trace probes, production tools, embedded software and software tools. Our vision is to simplify everyday life for engineers and end users.
People using these products are developers all over the world working with embedded systems. Our market-leading J-Link debug probe is the one piece of hardware that you will find on every embedded developer's desk.
Sega technology is inside everything. Space research, medicine, robotics, motorsports. You can find Sega everywhere.
With our technology, I hope we make people's lives better or easier.
My main motivation is seeing all these projects come to life and change the world or improve the world. Sega is the professional home for so many different people.
Developers, makers, engineers.
What unites us all are three words.
It simply works.
Welcome back after the lunch to what I've heard referred to as the nap section of the program. What I'm going to be presenting here is not as technical. It's a nice story modeled over a Christmas carol that I'm calling a freestanding carol. We will be visited by three ghosts: the ghost of emBO past, the ghost of emBO present, and the ghost of emBO yet to come. So, who am I? Hi, my name is Paul. I'm an electronics engineer, and fresh out of uni, as all electronics engineers, I knew that the only way to program microcontrollers was in C, until I saw how electrical engineers fresh out of uni program C, and I realized that I had to get something a bit higher level, something to help me. And luckily this was in 12, when C++11 was just coming out, that Bjarne described as a whole new language, and it really feels like that. By day, I am a firmware pilot at Trifork, consultancy in Denmark, and other places as well. And I've been part of SG14 almost since its inception. For those of you who do not know, SG14 is the subgroup under the ISO standardization that has to do with embedded and games and high-frequency trading, because they all want the same thing. So let's get on with the story, but I'm also a dad of two. And I know that sometimes there are those who don't want to listen to the story, they just want to color with their crayons. So if you are the kind of person who likes to doodle with crayons while listening to a story, you can pull this image. The link will be up at a later time as well, which will give you some nice C++ compilers to play with. So I'm going to start with the ghosts of emBO past in 2018. So embedded C++ was dead as a doornail. Not that I know what is particularly dead about a doornail. I would think that the most dead kind of ironmongery was a coffin nail. But here we were, in Bochum, like now. And we were having an entire conference mostly focused on embedded C++. So it couldn't be entirely dead, but it wasn't really all that good either. So the man who came on stage, I'm not implying that Ben Craig is the ghost of emBO past, but he came on stage and he had a presentation on freestanding. That he had just written a proposal for improving. This is in 2018, so 2017 was just released standard, and if we look in that, it says that a freestanding implementation is one in which execution may take place without the benefit of an operating system. Okay, so we get all the things we like without an operating system, and all the things that need an operating system we don't get. Like, for example, we of course need new because everybody likes dynamic memory allocation, and we also get RTTI because everybody likes dynamic memory allocation, and we also get exceptions because that's part of the language and everybody loves dynamic memory allocation. So Ben's idea was to expand the list of these headers to also include the parts of the hosted implementation that doesn't use problematic features. So this could be, at this point, for example, algorithm isn't there. So a for each was just too much to handle without an operating system. So let's try and get this in. Why would we do this? Well, from the motivation of the proposal, system programmers want to sort things, they want to use move semantics, they may even want to bundle the arguments of a variadic template, I see you, into a tuple. So Ben was presenting this, I was fired up, I was young and naive. Okay, this sounds great, I want to try this out. So where is this? Where can I get it? Show me the code. Turns out that Ben is primarily working on Windows drivers, so he doesn't have an operating system. But what he did do was enable some flags in Visual Studio, and then that was everything. Okay. So if you want something done wrong, do it yourself. So in 2019, I presented at emBO, freestanding on the shoulders of giants. And it's called freestanding on the shoulders of giants because while I did make an implementation and it's still there, I more or less just took the GCC implementation and hacked off the parts that I couldn't use. So unfortunately, 2019 was also the year when some of the hard drives were badly damaged for mysterious reasons. So it is not on YouTube. You just have to remember back because, of course, you were all there, right? Yeah, so just to give a short overview. So back in 2017, the proposal is submitted. At revision 4, so after 4 revisions, it goes to Hawaii, and they come back with the idea that it takes more revision. In May of 2020, it's presented to the Library Evolution Working Group, which is the group that evolves the library. If you remember back, Tabea, you might want to close your ears if you don't want to be traumatized again, but something happened around that time. So, yeah. Well, the long and short of it is that in 2021, February of 2021, Ben Craig closed the issue on the GitHub, declared P0829 dead because it was to be split up. So this is where we leave the ghost of emBO past. Any questions for this part? Great. So the proposal is supposed to be split up. So let's split it up. No, those are not variadics. Those are just freestanding is a very long word, dots. This is the story of freestanding as it stands today. These are papers in flight. For those of you who don't know, you might have also seen it on Chris's slides. You can take wg21.link/ whatever the paper number is, and you can magically get it up on your screens. You can do the same with STD or STD17, for example, if you want to go back to see what it was like back then. So that's a lot of proposals. I'll just go over some of them. So first one, this is actually merged in the C++23 standard, which brings us utilities, ranges, and iterators. All very useful stuff that you can use. There are some things that are not there. For example, the OStream iterators is not there today because if we don't want to do exceptions, dynamic memory allocation, all these things, doing streams is a bit more involved. So the stream operators are not there. Also, no, I guess the main problem is that it would need an OS because you would need somewhere to put it by default, right? So, but those are separate functions, and those are just not in freestanding. So this one gets us kicked off. We get a base of all of it. Everything's good. This is in C++23, by the way. So you might be able to use it sometime soon. Okay. Character primitives and the C library, also very important. Why, though? I thought this was about to be about C++. Well, this brings in C-string, which brings in memcopy, and a lot of the different algorithms is based on memcopy. So while this seems weird, it's not that weird. Also, how many here use the sized types, so uint8 instead of just char? Yeah, that's in there. So now it gets interesting because we have partial classes. One of the really interesting partial classes that I want to highlight is array, because we finally have a safe array that we can use. But what, anyone, shout it out, what could be the problem with array? Exception! Exactly. So the member function at is not available in freestanding, and that constitutes a change because now we have something that is a structure that is different in hosted and in freestanding. So this one is also a very important part of it. And of course, freestanding library, algorithm, numeric, and random. Because now we're getting to the place where, from the motivations, systems programmers want to sort. Sort is in here. Stable sort isn't, because it might allocate. It happens to be in GCC's implementation, but that's a side note. And one last thing I want to point out from that list is in-out expected span. Now, what do these have in common? They all entered the standard after the split up started. So this is just a grab bag of people forgot to actually make this freestanding. So I just want to leave you with one little quote from the standardization process. Someone voted in favor of it and commented that it would have been really nice to not have it split up so that we wouldn't waste the LEWD's time. Well, you get what you want, what you ask for, right? So, what is now in freestanding libstud C++? Because the work I've been doing based on libstd C++, if you just pull a trunk right now, we already have parts of these classes put in. And if you want the rest of it, then this is where we're at today. So if you go pull that image, you'll get these. This is where we're at today. MDSpan is not implemented in GCC, and as I said before, I just took GCCs and hacked off the dirty parts. So because MDSpan is not in there yet, it's not in the freestanding implementation that you could see. There's a question. So the question was, we get an array from one of them, but do we also get other containers? Short answer, no. We get spans and string view, but owning containers is, for a large part of it, is allocating, unless you do something for it. And what default should you pick? So if you're going to make your own version of the container, you might as well make the container. Yes? You always thought that the PMR versions could be. I did as well. There is a reasoning why it can't be, and I can't remember it right now. But I believe that it requires everything to fall back to actually have an implementation. So. Yes. So just to reiterate, in order to be able to have the whole PMR stack that you define yourself, there has to be a bottom layer. So, and that bottom layer, what should that be when you, for example, don't have a stack at all, or you have two different stacks with different properties. So again, we can't do something where we would have to have an operating system have some sort of idea. Just let me check. Yeah. So if you want to try out what is available today, as I promised, here's the link again. As you can see, this is built off of GCC 14.0.1, which is not a stable release. It is some sort of last time I pulled it and built it. There is also the Docker files if you go to the GitLab page, which I will get to later. But this one contains the compiler for AVR. It contains the compiler for ARM. It contains Ninja, CMake, and the CMake toolchain files to make it all run. So this should be enough to get you into a playground. For those of you who are optimization freaks, which I guess is more or less all of you, the ARM non-IABI does not have the nano spec, just so you are aware. So it might be a bit bigger than you'd want it to, but that's not really not what I was focusing on. So, as we leave the ghosts of emBO present, are there any further questions? Yeah.
Like exceptions for our things. So what do we do instead? Because particularly stitched area becomes pointless almost if you don't have some.
The comment is, what do we do for error handling if we don't do exceptions? First of all, exceptions are there if you want to do them. It just gets really messy when you try to do it. For array in particular, you'll need to guard how you access it. And for error handling in particular, you have things like expected, which, thank you, that was unexpected, which is, it's not on the list because that was made with, it's one of those things that were made with freestanding in mind, or at least someone came to the author and said, hey, you should really do some freestanding off of this. So those faculties are there, and I guess if you can wrap it in that, then that's how you use it. But the fact remains that even without @ I would argue that std array is still a whole lot safer than just using a C array, because you can, for example, just iterate over it because you know stuff about it. Great. So, as we say goodbye to emBO present, let's look into the future, to emBO yet to come. So what isn't specified or in some of the proposals yet is chrono and random. And that has to do with the fact that, does chrono and random require something to be in an operating system? Well, it might, but there are also things in there that doesn't. And there should at least be a way to specify your own time points and your own randomness. So we had a nice presentation just a moment ago going over the internals of the ARM processor, and there's a true random generator in there. Of course, we can just write our own. There doesn't have to be an operating system for us to use our own random source, but the faculty should be there. This is just not done yet. There might be coming other things down the line. Example, executors, or senders or receivers, or whatever you want to call it. These are currently not specified to be freestanding, but parts of it might actually fit very well. So things are coming along. The top two are the things that are from P0829 that hasn't been split into a paper yet. And I'm sure that if you want to help along, and the rest of the community would really like the help. So let's take a look at emBO++ 30. So now we're as far into the future as Ben Craig proposing this, finally coming into the standard. So what could be some talks that you might want to give in a couple of years. No more roll loops, perhaps except while one. We can finally get our algorithms. We can finally get what Sean Parent was talking about in what, 2012 with C++ seasoning? We can finally do it. Still can't do gather because stable partition might allocate, but hey, we're part of the way there. Fun fact, stable partition is not in because it is allowed to allocate in order to be faster in big O notation. So the standard decided, let's not have a silent degradation of performance by going to freestanding, so it's not specified as freestanding, but anyone can make their own additions to freestanding. So GCC was like, yeah, okay, if we're on freestanding, just don't bother with the allocation, just go to the slow part. So you can actually do gather on the Docker image. Embed some signal processing in standard C++. We're getting MD-span as soon as GCC implements it. That's really nice for doing matrix multiplication and stuff like that. And all sorts of different signal processing. The original goal for me was to have something to do an SDR on an 8-bit AVR. SDR is a software-defined radio, so doing radio processing in very little place. And with things like MD-span and with linear algebra proposal, may they find a better name, coming down the line, this is also something that would be able to be implemented in a smaller system. So please come and show me that. Using senders and receivers with interrupts. We saw that you could do it if you just write your own C++ operating system, so just go do that. Otherwise, if you're still on bare metal, maybe it can be done. Spoiler alert, check out Meeting C++ with my name about a year ago or two. It may or may not have something in that line, but I'm sure you can do better. Yeah.
And it's interesting that it's the last one that's kept. And I wonder why nobody proposes to just use a do without a while and then break inside the do and make this one the endless loop. So like do, and there's no while condition. No do while, just do, and then break inside of that. Because I think it's more intuitive than saying while.
So why is there no do without a while? Two things. First of all, when you are in a desktop system, and this is primarily where the most of the C++ community that goes to conferences and goes to standardizations meetings and goes places, not necessarily if we talk dark matter, but most of them are on desktop systems. They're at Google and stuff like that. And do forever is, it's not always a good thing. You don't always want to do it. The other thing I wanted to say is write a paper. Because I have to. That's the standard reply. Why isn't it in the standard? Because no one has sat down and written the paper. And let's move a little away from the freestanding stuff. Microcontroller modules, couldn't that be cool? Who here has heard, Odin has heard about modules. Has anyone else heard about modules? What did you say? For the record, everyone? And really hope that's the next slide. Yay! So don't worry too much about the code. This is just proof of concept code for God bolting, because he's a verb. But this is just a little peek of what we'll be able to do. So we import STD, whether it'll be STD freestanding or whether it'll just be import STD and we're in a freestanding environment. Let's find that out. If you want to pitch in, there's a committee you can be part of. But we have stuff like std pair, we have std swap. We can do stuff that is at the higher level. Also, someone said that you shouldn't be doing volatile declarations of variables, and this is what you should really be writing instead. The Linux kernel has it packed in a macro. But yeah, that's how you avoid having compound. That's how you avoid having volatile compound assignments tear, which is apparently a problem. Enough that someone had to make a proposal. So, this is where we end the tale. I hope that you found the travel a little bit more enlightening and enjoyable than the original. But I'm also hoping that, like in the tale, we will all be happier for what has happened.
Thank you very much, Paul. So, where are the questions? Where do I have to run? Right, Florian.
Hey, and I'm under time. Woo! Had to happen at some point, right?
So, thanks for the presentation. It was cool. But I was wondering if the freestanding, well, the people working on freestanding environments have considered using or introducing other error handling mechanisms rather than exceptions to allow for more complex or more maybe dynamic behavior, such as vectors and ats and whatever, in the freestanding environments by using, for example, something like expected or a result type or something like that. Introducing that in the standard might make it so that we can use more of the complete standard library on freestanding platforms. Is work being done on that?
Short answer, no. Long answer, you're right. But that is something that needs to happen to the entire C++ ecosystem. And I'm pretty sure that std vector isn't going away anytime soon. And I'm also pretty sure that standard vector is not going to change its ABI anytime soon. So it would have to be something that is entirely different. But that's entirely possible. It's not something that I know of that there is being worked on. But the thing with C++ is that it's, for a large part, it's just a couple of people who are allowed by their companies to go spend some time on making it better for everyone. Believe that you're still allowed to send a proposal if you feel like it.
Next question.
So, hello. Have you tried building some C++ applications that are not built with... they're built for microcontrollers, but not with enabling freestanding. But have you tried building them again with freestanding to see how this works in the real world?
Yes, I have tried. So there is one thing that I keep hitting on all the time. This goes for StdFMT. No, not StdFMT, but the FMT library, which actually has a part of it that you can use without any dynamic memory allocation. It's really great. Unfortunately, it uses CAssert. And is that a big problem, you think? Well, CAssert isn't one of the C things that came along. And how is it that you're going to do a CAssert on a microcontroller? Where are you going to put the message? So the main hurdle I've hit trying to get the SIB library that Luc Valenti presented, was that last year or the year before at emBO? The problems I've encountered with the FMT library, and whenever I pick up a cool library and say, this will be so cool, I can use this, then for some reason they all use CAssert. So, but pulling that out and getting it to work, as I said, I have 2 kids, you can do that.
Okay, that was unexpected. I thought that there would be more hurdles. But second question, if I may. How does different RTOS comes into freestanding? Because you can, to some degree, agree that FreeRTOS or NATix or CPPOS is an operating system.
Yes. Breaking news. So I have been in contact with some of the upper layers in the Zephyr organization, mostly because we're friends from our hackerspace. Apparently Denmark has like 3 or 5 or 8 of the top Zephyr maintainers in the world. But we went over this, and the thing is, first of all, Zephyr, and a lot of them, are written in C, and are about as happy about C++ in their code base as Linux is. For the record, it's not very happy. But it might be useful, it might be usable, but as you say, on something like Zephyr or FreeRTOS or whatever, QNX, you're on a hosted platform. You do have the ability to make a PMR allocator that has a default. But inside of the core might be somewhere where freestanding C++ could be used. I don't know yet. It's an interesting thought, but generally you're right. It is a hosted platform. Allowing C++ inside of the kernels is always a fun struggle, and it's very slow and technical.
All right. Any other questions? If not, then thanks once more, Paul. And I don't know, and no, thanks.